In this example, we are looking to, we have our function, says find for what values of x does the line tangent to the graph have a slope of 6? All right, so there's the key. Slope of 6. So we have our original function, and we're trying to figure out when the slope of this thing is 6. Don't know. So first thing we do is let's find our slope equation, which is us doing the derivative. All right, so we'll do the power rule. We do the derivative of this, the power is going to come down. It's going to be 6x, and then we're going to drop the power down 1. So we're multiplying 3, dropping it down, and then minus 2 times the 15 is 30, and then x to the first, and then plus derivative of 1. So the derivative of a linear is just going to end up being the coefficient. All right, so there's our derivative. There's our slope equation. So if we have a slope of 6, that means we're going to take this derivative, this slope equation, and we're going to set it equal to 6. All right, let's see. We have a quadratic. There's potential for 2 answers. We don't know. Let's kind of figure this out. So we'll subtract the 6 over. So if I subtract the 6 over, that's going to make this 6x squared minus 3x plus 18 equaling 0. All right, so I lost a 0 on there. 30. All right, so we can take a 6 out. So that's x squared minus a 5x plus 3 equaling 0. All right, so ideally we're looking to see if this thing can factor, but bad news is we have nothing that's going to multiply to 3 that's going to add to -5. The 6, technically, we could divide the 6 over to the other side, and we are trying to solve, like that 6 doesn't have a variable on it, so it's not going to get us any additional answers. So what we're really trying to do is figure out what this is. So the bad news is it's not factorable, so plan B is usually quadratic formula. So x is going to equal negative b plus or minus square root of b squared minus 4ac, so 1 times 3. And that's all going to be divided by 2. All right, so if I do this math, I'm going to get a 5 plus or minus 25 minus 12 is 13. And here's really the reason of why, well, a hint to why this kind of reaffirming that this was not factorable. If that was a perfect square and we have these whole numbers, then actually that meant that that piece would have been factorable, but can't square it to 13. So, all right, so there's our 2 answers. Let's make some sense out of this though, right? So we have one answer is 5 plus the square root of 13 over 2, and the other one is 5 minus the square root of 13 over 2. So we get answers of, if I throw that into a calculator, I'll get about 4.303. Or if I throw that into the calculator, I'm going to get about 0.697. All right, so what does that mean? So let's get a rough idea of what we got going on here. So here was our original equation. Our graph is an x to the third, and it has a positive, so end behaviors are going to go up in one direction. So up in this direction, down in this direction. So let's say the graph looked something like that, right? I don't have to be too specific on it, just trying to get a rough idea. And we're looking for when this graph had a steepness of 6. So like, where is the slope up 6 over 1? Right, so this graph is constantly getting steeper, so maybe here could be one point of where it might have that kind of a steepness, and then maybe here for another point for that kind of a steepness. So could we have 2 points that have a positive 6 slope? Absolutely. If this was a negative 6, then we probably would have only one somewhere inside of there. But that would be us setting it equal to -6 and just kind of having a different answer to it. But is it possible for 2? Yes. So slope of 6 at 2 locations. And so that's why we're getting are these 2 answers. So here's our exact answers. Here's our approximations. The approximations, if I really wanted to graph this accurately and all of that stuff, I could use the decimals then to really kind of pinpoint, hey, here's potentially where these x's actually line up very nicely. So that was us finding a slope of 6. So us finding a slope equation by doing the derivatives and e equals 6 and finding those solutions for it.